Welcome to 6.1, Writing Conversion Factors from Equivalent Measures. So this is something we've kind of already been working on, converting between units. We're going to go ahead and do that. One of the big differences now is we're going to show how we do the canceling of units. So we're going to be setting up our proportions a little bit differently, but pretty much just like how we've been doing them before. So conversion factor. A conversion factor is a fraction or a ratio made of two quantities that are equal to each other, but expressed in different units. For example, if you wish to convert between days and weeks, you would start by recalling that 1 week is equal to 7 days. So for the first example, find conversion factors. Go ahead and write down some conversion factors you think of for A, B, and C, and then check in with me and see which ones you get. Well, for 1 week, I might think of 7 days. Okay, but in 1 week, there's also another conversion factor you could do. How many hours is in 1 week? Well, it'd be 168 hours. So those are two possible conversion factors. 1 week is also the same as 168 hours. So notice the units are different, but they're still equal. Okay, so that's the thing about a conversion factor. These two look nothing alike, but they are in fact equal to each other. So one day, you could do 60 minutes, 24 hours. 60 minutes, you could do 1 hour. Or you could even say 3,600 seconds. Okay, so there are many different conversion factors out there, and you just have to find the one that works for your problem. So right now we're going to work on a few more equivalent measures from page 105. They are found on page 105, but we're going to write them down for now for our notes. So 1 grain is the same as 60 milligrams. And please note, I'm going to be asking the VET program exactly which items you need to have memorized and which ones you can just reference on the go. I'll be letting you folks know that hopefully by the end of this upcoming week. One gram equals 0.06 grams. 1 milligram is 1,000 micrograms. So notice these are weight values, okay? 1 gram is equal to 1,000 milligrams. 1 pound is equal to 454 grams. And then last in this column is 1 kilogram is equal to 2.2 pounds. One for certain I will say that is very important to remember because these conversions happen a lot, and the VET program mentioned this was important, is conversions between kilograms and pounds. So definitely knowing that one. Alright, now volumes. 1 teaspoon is equal to 5 milliliters. 1 tablespoon is equal to 15 milliliters. 1 ounce, and notice this is a fluid ounce because we're in the volumes. So 1 fluid ounce is equal to 2 tablespoons. And then 1 ounce is also equal to 30 milliliters. Okay, so notice this is where you have 1 ounce has two different conversion factors that we're mentioning here. And 1 cup is equal to 240 milliliters. 1 pint is equal to 480 milliliters. Almost there. 1 quart is equal to 960 milliliters. Ooh, so many little L's and dots there. And 1 liter is equal to 1,000 milliliters. Looks like I have an extra column here. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Yep, had an extra column there. Did not need that. Or an extra row. All right, so we just need to find the conversion factor for example 2. So we're going to use our chart above. So if I was trying to figure out going from pounds to grams, which conversion factor would I use? Look for pounds, look for pounds. Pounds to grams. Aha, I have found it. I would use that conversion factor. So I'll go ahead and write that down. 1 pound. I'll use the abbreviation. 1 pound to 454 grams. And that's the fraction form. Let's go ahead and write it as a ratio. 1 pound to 454 grams. All right, go ahead and find the conversion factor for part B. So we're trying to figure out 7 cups to how many milliliters. So we're going to look for cups and milliliters. Aha, right here, we found it. I'll go ahead and write those down. 1 cup, 240 milliliters. Oh, I could have just used C for cup. And then 1 cup, I'll just go ahead and write cup, 240 milliliters. Okay, there we are. We were just going to write the conversion factors for those two. So now we're going to take a look at how to solve converting units using both ratio and proportion. I tend to like the proportions myself, but if you find the ratio way easier, by all means. So our conversion procedure checklist. So first things you always need to do is find your conversion factor with the units you need. After that, we're going to write a fraction with the unknown x or proportion. Okay, so or proportion. Sorry, not an or proportion, or a ratio. Set up the fraction as a proportion, or also as a ratio. Cancel units, and then for 5, cross multiply and solve. That is also for if you're looking at it as a factor. For ratios, you would just continue with solving for step 5. Okay, so once again, I tend to stick with the fraction proportion version, which is the one we've been using most of the time. But if you find the ratio method simpler, by all means, you may use it. All right, so converting, for example 1, we're asked to convert 2 teaspoons to milliliters. So what we're going to do is set this up a teeny bit differently than we've set it up before, because I'm going to show you now how we're canceling units. Okay, so it's a little different. Please note that. We have 2 tablespoons to x. Okay, we're not including the units in x. And then we're setting that up to, well, I know that 1 teaspoon is the same as 5 milliliters. That is on our chart. You can go ahead and check your chart. Okay, so solving, as we've done this before, we're going to go ahead and cross multiply. And then we'll get x times 1t equals 5 ml times 2t. And then this is where we're going to go ahead and do this thing called canceling the units. So see the t from both sides? We're going to take away the t. You could say you're dividing out the t's. The t's cancel, and the only unit we are left with is ml. So multiplying the 2 and the 5, we get 10, and then our leftover unit ml. Okay, so that is how you work with canceling out the units. So 10 milliliters. Okay, go ahead and try set up the proportion for B. Alright, hopefully you pause the video and tried it yourself. But we have 75 pounds, and we're trying to figure out what that's going to be. Okay, so let's see, what do I know? I know that 2.2 pounds is the same as 1 kilogram. I'll go ahead and cross multiply. And I get x times 2.2 pounds equals 75 pounds times 1 kilogram. Go ahead and cancel out the units. Then I have x times 2.2 equals 75 pounds. All right, let's go ahead and divide out by 2.2 to get x by itself. And then dividing out by 2.2, we end up with x equals 34.1 kilograms. Okay, once again, converting from pounds to kilograms is something that happens often from what I've been told by the VET program. Alright, next example. That should be example 2, I believe. Solving using ratios. Okay, so we're doing this differently. So for the ratios, when we're converting, so it's pretty much these are the exact same problems, by the way, just showing you how to do it differently. So what I'm going to do is set up the proportion, or the ratio, like how I would. So we don't know how many teaspoons there are to 2 teaspoons. Okay, so how many to 2 teaspoons? And then we're going to set that equal to, so here's the weird notation for setting it equal to when we're using ratios. Set that equal to 5 ml over 1 teaspoon. Alright, so we set it up this way. As you can already see, to me there's so many dots going on, it's a little confusing. And then what we're going to do is we're going to multiply the means. So these guys here, the inner ones, are the means. And then multiply together the extremes. Okay, and when we multiply that out, what do we get? Well, we get x times 1 teaspoon. Oh, I noticed I wrote that out differently both times. And then equal to 2 teaspoons times 5 ml. And then same as we did before, we'll go ahead and cancel out the units that are in common, which happens to be the t's. And we'll be left with x equals 10 ml. Same answer as we had above. If you notice, they are the same, different methods, but same way to get there. Okay, go ahead and try set up B by yourself. Alright, setting up B, we have the unknown quantity over the known quantity, 75 pounds. Set that equal to the conversion factor that we know. Okay, and notice for the conversion factor, the first ones are the kilograms and the second ones are the pounds. So just like how normally for per proportion you'd have the pounds on the top and the kilograms on the bottom, for ratios you have the kilograms first and the pounds second, or vice versa, depending on how you want to set it up. Okay, so let's go ahead and multiply the means and multiply the extremes. It should be over there to that x. And we get x times 2.2 pounds equals to 1 kilogram times 75 pounds. Then we can go ahead and cancel out the pounds from both sides. And what do we have left? We have 2.2 times x equals 75 kilograms. Once again, we can go ahead and divide out by the 2.2 to solve for x. And plopping that into your calculator, you'll end up with x equals 34.1 kilograms. Alright, so moving on to the last page for chapter 6. Let's look at this, our examples. So a patient weighs 65 kilograms. How many pounds does she weigh? Alright, I'm going to go ahead and solve this one using a proportion. So setting up my proportion, we know the patient weighs 65 kilograms, but we don't know how many pounds. And then I'll set that equal to, let's see, what's a conversion factor we have for this? Well, I know that 1 kilogram is equal to 2.2 pounds. That's my conversion factor. Okay, so setting that up, the kilograms goes on top, pounds go on the bottom. Let's go ahead and cross multiply. You can pause the video and try to solve by yourself, and then check your answer with me in a second. we can cancel out the units. The kilograms are out. And then we are left with x equals 2.2 times 65 pounds. So x equals 143 pounds. If you want to set that up for a proportion, for a ratio, you would do x over 65 kilograms, or this would be one way you could set it up, and then 2.2 pounds to 1 kilogram. I tend to not like this way quite as much, but you could choose that method if you want to. Okay, I'll go ahead and use the ratio method for B. So the ratio method, we have how many kilograms is 187 pounds, setting that equal to the conversion measure that we do know, which is that one right there. So let's see, the kilogram should go first. So 1 kilogram and then 2.2 pounds. We'll go ahead and multiply the means together. And then multiply together the extremes, so the outer one's extremes. And that gives me x times 2.2 pounds equals 187 pounds times 1 kilogram. Go ahead and cancel out the pounds, and then we are left with 2.2x equals 187 kilograms. Then solving for x, we've got to solve for x, we're going to divide by 2.2. And then we have that x equals 85 kilograms. Okay, one thing I forgot to do with the first problem is these are word problems. I need to write a sentence. So she weighs 143 pounds. And then for our next problem, how many pounds does he weigh? Well, he weighs 85 kilograms, period. Okay, please remember to put your complete sentences on your exam notes. I do grade for that on exam notes. Alright, so a physician orders 2 fluid ounces of liquid medication. How many tablespoons should the patient take? Okay, pause the video, go ahead and choose either way you would like to try and solve this problem, and check back in with me in a second. Alright, so let's go ahead. I'm going to go and choose with the ratio option, which is the one I like the best, the proportion. Sorry, I take that back. The proportion option is the one I like the best. So 2 fluid ounces to x. Now I need to find my conversion factor. Well, I know that 1 fluid ounce, okay, you're going to have to look in the volume section of that chart from page, I think it was 105. Yeah. 1 fluid ounce is equal to 2 tablespoons. That is our conversion factor. So we have 1 fluid ounce to 2 tablespoons. Let's go ahead and cross multiply. And then we have x and fluid ounces equals 2 tablespoons times 2 fluid ounces. Well, we can go ahead and cancel out the fluid ounces unit, and we're just left with x equals 4t. And my final answer will be the patient should take 4 tablespoons. So if you wanted to set it up as a ratio, the ratio version, one way to do it would be x over 2 fluid ounces equal to 2 tablespoons over 1 fluid ounce. And then you would go ahead and multiply the means and the extremes. And I might as well finish this off. So it's going to be x fluid ounces equals to 2 fluid ounces times 2 tablespoons. We can go ahead once again and cancel out the fluid ounces from both sides. We don't cancel out the tablespoons because there's no tablespoon on the other side to cancel it with. And then we have x equals 2 times 2 tablespoons. X equals 4 tablespoons. So both of these methods do work. And that is it for Chapter 6.